Hello friends, today I am going to solve LeetCode problem number 139 word break. So we are given a string as and a dictionary of strings word dict, and we are going to return true if as can be segmented into a space separated sequence of one or more dictionary words. So what does this mean? Let's look at this example over here. We have a string as and we have the word dict. We have the words leet and code in this word, and in the string we can divide this word into two segments, leet and code, which are present in this word dictionary, right? So that is when we return true. And we need to note one thing, that we can use the same word in the dictionary multiple times. So in this example we have a string as and word dictionary with two words apple and pen, and in this string we can actually divide this string into apple, pen and apple. Since we are able to break it down into the words in the dictionary, we return true. Now what about this string over here? Let's look at that string in this example over here and see how we could solve this. So what do is we need to first start from the first character to see if that's a word in the dictionary. So basically C is not a word, we check CA is a word, no, then CAT, it is a word, so we found CAT as a word. Since we found CAT as a word, now what we do is we need to check the remaining of the word substring if that can be broken down into words in this dictionary or not. So starting from string as, that is this index, we check if that's a word or not. It's not a word, we check SA, then we check SAN, then we finally check SAND, and we found it's a word over here. And then from this index next character we check if that's a word. It's not a word, so we go on and check if OG is a word. It's not a word. And finally we reach the end of the string, and we have not been able to divide the last substring into a word. So what we do is next we try to backtrack and we check if SANDO is a word. It's not, right? SANDOG is also not a word. So we again backtrack to our previous word, that is cat, and we check if cats is a word. It's a word over here. Then starting from the next character A, we check if the remaining substring can be divided into words. So we start from A is not a word, AN is not a word, AND is a word, right? Then we start from the next character O, and now we see that we have reached the same point where we were previously, right? That is, we are doing the same task again. So why do the same task again? Let us save the previous result in a cache memory, right? In that way we will be able to save a lot of time. So that is what we are going to do. Now let's talk about time complexity also. So how can we solve this problem in an optimal time complexity? So let's first find the time complexity of this solution. So basically what we are doing is, for each of the character we are actually forming a combination with all the rest of the characters to see if it's present in a dictionary or not. So in worst case we will be forming for C we will be combining it with all of the characters, so that would be n time complexity, and we will be doing it with each of these, right? For A also we'll be doing the same, for T also, so that would be O of n squared time complexity. So previously we were checking for each of the substrings if it matches any of the words. Now what we are going to do is we are going to check if these words match the substring in this string. Okay, so basically we start from the first character. Okay, so at index I equals to 0. Now we want to check if we can form a substring of any of these. So basically we check for each of the words, can we form a substring cat starting from I equals to 0, or dog, sand, and the other one is and the last one is cat. Okay, so we are going to check for each of these, and we know that starting from index I equals to 0 we have cats over here, right? So we can form this word. So when we form this word, what do we reach is, now our next index would start from I equals to 4, right? We need to check from starting from that index. Okay, next we also check if it can form a word dog. It cannot start from I equals to 0. No and but from I equals to 0 we can form a word, a substring cat right here. So we have this word in our substring, and that would result us in starting from I equals to 3. So now here we have I equals 4, I equals to 3. So starting from I equals 4, that would be starting from this index 4. Can we again find any of these words here? So what we do is we check if we can form cat. Okay, so what we do is we check. We cannot form a cats, so we cannot form a cats, we cannot form a dog starting from index I equals 4. Okay, but we cannot form sand, we can form and, right, starting from index I equals 4. And that would lead us to which index? Since this is of character 3, so we can form and that leads us to index 7. So now we need to check starting from index I equals 7, and we cannot form cat over here. All right, so starting from I equals to 7, we have O, and we check if we can form word. We can find these substrings, this word starting from index I equals to 7. So basically we check for each of these substrings, and we know that we cannot form cats, dog, sand, and cat, neither of these. So we cannot form any of these over here. So what we do is, now we have these also, right? So we branch out from this one and we want to check for these two. So okay, cat. Okay, so basically we cannot form cats, we cannot form dog, because it starts from index I equals to 3, and I equals to 3 we have character S, so basically it should start from S. So sand, here we have sand, and from starting from S we can form sand, right? So here we form sand, and then we reach index I equals 7 again. So we reach index I equals 7. So basically we are doing the same thing again, the same calculation again, and if we use a memory we will know that we cannot form any word from I equals to 7 as well, and we cannot form any of the word from these two as well. So we'll know that we will not be able to find, segment this string into words in this dictionary, and we return false. Now let's look at a problem where we can actually segment the word into the words in the dictionary. Okay, so what are we doing here is, now I'll show you the approach we are going to use to solve our problem in coding. Okay, so now starting from the bottom up approach, so we start from the first index, that is I equals to 0, right? But starting from an index I equals to 0, we check for word lead and we check for word code. It matches the word lead, right? So it matches the word lead. Now we need to check for started from index code. But basically what we will be doing is, we will actually be creating two for loops here. Okay, so we will be creating two for loops. The first for loop we will be starting from index I equals to 0 of the string until the length, that is n minus 1. Okay, here in this case n is equals to 8, and let m be the length of the word dictionary, and within this for loop we are going to check for each of the word. Okay, for each of the word in the dictionary. So what we do is, starting from I equals to 0, now we check is lead. We can form lead, right? So we are able to form lead. And now next we check, can we start from E and form any word? Where we cannot form any word starting from E. So next we check starting from E again. And one more thing we need to check while we are doing this is, okay, we found a word lead. Now to check for a word starting from E, we also need to know that any word before that has already been found. So starting from the second character, we only have one character before that, and that is L, right? And L is not a word. Now how do we know L is a word or not? If we need to find, let's suppose that we have found lead. Now to starting from C, we need to know that these have already been found. Okay, these words can be segmented, so we need to mark this word as mark something as true, right? So what we do is we mark the index at C equals to true. Okay, so basically here, when we are starting at index I equals to 0, we need to mark the index at this position as true as well, which means that any word that's formed before the first character, that was basically an empty string, is also found in this word. Okay, so that means that thing. Now while we are forming our word, we found a word lead. Okay, and we ended up at index 4, so we mark this index as true. Next we start from E, and then starting from E, we need to first check if the word at index 1, that is index where we are starting, is true. It's not true, we will mark all false. Initially everything is false, and since everything is false, it's not true. Okay, so we cannot, that means that we have not formed a word for all the characters before that. So we again start from the third character, and then we start from the fourth character, that is T, and we know that lee is also not a word. So next we start from C. So when we starting from C, we know that leet is a word because index 4 is marked as true. So basically we can check if starting from C we can form a word, and yes, we can form a word. And while we are forming a word here, we end up at index I equals to 8, right? So that is where we mark this as true. So when we see that index I equals to 8, that is the last index, we actually go out of this length index, like that index doesn't exist, it's equals to the length of the string. So when the dp at the length of the string is equals to true, which means that before 8 index, which is before that is 8 index, that is all the characters in this string has been found in this word dictionary, and hence we return true for this solution. So this is one approach, that is bottom-up approach, because we are starting from the first character and moving backwards. Okay, now we can forward, actually we are moving forward. We can also solve this using top-down approach. In that approach also we are going to do the same thing, that we start from index I equals to, but not 0, we are starting from backwards. So we start from index I equals n minus 1, and we move on to until index 0, and we iterate over each of the word. And in that case we do not mark index 0 as true by default, but we mark index 8, that is the last one, length of the string, as true, because we know that if we reach the end we have found it. Now from end we need to go forward. So here our assumption is that we have found all the strings after index starting at index 8 in the word, which is basically empty. Now starting from index 7 we do that thing, that is n minus 1 is 7 here, right? Because n is equals to 8. So starting from n equals to 7, we check if E is the word, so we check if these two word matches, it doesn't. So we start from index 6, it's not a word, 4, and finally we start from index 4, right? And we check it with lead, it doesn't match, we check it with code, it's a match. So now we know that code is the word. So starting from index 4. It's starting from index 4, so we mark this as true. Now we know that we can divide string starting from index 4 as true. Now we start from the next previous index, that is t, and we check if it could form a word or not. So for t we cannot form a word. Then we take et, we cannot form a word. eet, we cannot form a word again. So we take leet, and we can form a word using leet. So we mark this as true. And now since that we have reached our 0th index and it is true, that is when we return true. Okay, so this is basically top-down approach, because we are starting from the last index and we are moving to our first index, that is 0 index. So now let's try to solve our code using both the methods. So I'm starting from the bottom-up approach. Okay, bottom-up dp. So let's first create our dp, which is an array of length n plus 1. And what is n is equals to the length of the string. Okay, now that we have our dp, we need to iterate over each of the length, right, each of the characters. So since this is bottom up, we start from the first index, I equals to 0, I is less than n, I plus plus, and for each of the word dict, right, so each of the word in the dictionary. Now we are going to check. Okay, so one thing we need to keep in mind is that this word should not be greater than the length of the substring in the string as. And what if, let's suppose, what happens if our string as is equals to lot and our word dictionary only has the word lot as? So we would, starting from index 0, the length here is equals to maximum of 3, but this length is equals to 4. So basically there is no match at all. So we need to take care of this base case. If starting from I equals to 0, so I minus word length, and we also need to take care of minus 1 again. So what happens is, let's suppose we have lot and lot. So starting from I equals to 0, so when we are adding at this index, we are adding this length, right? So the length is equals to 3. So this should be okay, less than, if this is greater than n, then we return, I mean not return, we continue with next word. Let's suppose we have lots and we have lot 2. So 2 lots, index I equals to 0, the length is equals to 4. So 4, this becomes equals to 4, and length and which is the length of the string is only equals to 3. So we only have 3 characters here, but we got 4. So we are not able to continue, we will not be able to match this thing, right? This basically, this word will not, this string cannot be broken down into this word because it's greater, this length is greater, right? So we move on to the next word, we move on with comparison with next word, and this is of length 3 and this is also of length 3. So when we add the length 3 to index I, which gives us 3, is and this is also 3 and this is not greater, so it's equals to 3. So we move on to the next if statement, and here we are going to compare our word. So sub as dot sub string strng string, so we are going to take the substring which is of length of this word from this string. So that would basically be I plus, starting from index I plus word length. Okay, and this should match the word that we are comparing to. And also in the case of bottom-up approach, as we are going from top to down, we need to know that we are able to create breakdown words before that. So if we are checking start from index 5, we need to know that starting from index 4, we need to know that we are able to break down all the words and the substring before that index into words. So we need to check dp at index I should be equals to true. And also for bottom-up approach, by default dp of 0 is marked as true, because all the words before index 0, substring before index 0 is basically an empty string. An empty string is a match in this word dictionary. Okay, so that's why we mark that as true, and that's our base case. And if this is true, then we mark dp at index I plus the length of word also equals to true. Okay, and finally we need to check if we have reached the last index, that is the length. If that's true, then we are just going to return true, else at the end we return false because we did not find any solution. Now let's try to run our code and check if this works. Okay, awesome. Let's try to submit this. Great, so this one worked, right? Now let's try top down approach. So for top down, it's just that we reverse this string, everything will be the same. Okay, we need to fill this with false. Basically null, empty, nothing also means false. And here we are going to mark the last one as true because we are moving from backwards. So moving from backwards, here we mark this as true, and every string starting from this index is basically found in this word dictionary. That is what it means. And here we are moving backwards, so starting from n minus 1, I is greater than equals to 0, I minus minus, and we are going to check for each of the word. And here here we need to check I minus the word length is greater than equals to 0. Okay, so that is, if that is less than 0, we skip the next step and we continue with the next word. Let's take this example. So as we are starting from the last index, that is index 0, 1, 2, and 2 minus, we take the length of this, which is equals to 4, and we need to take a plus 1 here as well. Basically plus 1 here. So this would mean index I plus 1 means the length of the string overall and the length of the word. So length of the string should not be less than the length of the word. So if that's less, then basically we cannot compare. So this cannot be compared with this one, so we move on to the next string. Okay, and if that is comparable, then we check if the string starting from index, okay, starting from index I minus length plus 1. Okay, so that will give us the starting index of the word. So let's take this example. So in this we have the last index 2, and the length is equals to 3. So 2 plus 1 is 3, 3 minus this length is equals to 0. So basically we are checking the substring starting from index 0 until index I, which is I last index plus 1 here. Okay, so it equals to the word, and dp of I plus 1 should be true. That is when we mark this word as true. Okay, and then if dp of 0 is true, then we return true, else false. Awesome, let's try to submit this one. Great. So as I already told, the time complexity of this one is O of n times O of m, and if we consider the comparison of the word, that would be the length of the word, so that would be O of k. So then the time complexity is O of n times m times k, and the space complexity is O of n, as we are using a dp. Okay, hope you liked my solution. Let me know in the comments down below.